My name is Amitai Rotem. My colleague here, Randy Trait, we're from the Windows Defender engineering team, and somewhere here, Heike Ritter is our product marketing manager right there. So later on when we have questions, she can also help us. Before we get started, how many of you are actually using Windows Defender in your organization? Oh, quite a lot of you guys. That is actually surprising. How many of you have cloud protection on? Oh, very little. OK. How about using SCEP? OK, great. So by the end of this talk, I have two goals. For those of you that are not using Windows Defender, get you to at least try it, look at it, think about it. Those that are using Defender, the majority of you guys, turn on cloud protection. Hopefully, that's going to be extremely clear by the end of this presentation. We're going to talk about how we use our big optics to really fuel that cloud protection. Randy's going to do a really cool demo. That's really going to be our highlight of how we use that demo, that data. And we're going to talk about the endpoint, because at the end of the day, without a strong endpoint, something on your computer is running, there really isn't any anti-malware. We know we weren't great. A lot of you that have been using us for a while, you know that we really weren't there. We put a lot of effort the past year or two. We want to show you that and show you what others think about that, including the AV test organizations. And so let's get started. I introduced myself. I'm Amitai. That was Randy. We are Windows Defender. But you might have also heard about System Center Endpoint Protection, SCEP, Forefront Endpoint Protection, OneCare, Microsoft Security Essentials. I'm sure to some of you here in the room, you've heard all of these names, or at least some of them. They're all basically Windows Defender. Over the years, we've been using the same common anti-malware platform in all of them. They were kind of branded for different consumers versus companies, whether you're using System Center or you're not. We have really aligned now to one brand name. So if you come up to me and you're like, hey, I'm using SCEP, how do I get to Windows Defender? I'll just tell you, you're already using Windows Defender. Over the past week, you probably heard a lot about security here. I'm kind of going to show this again because it's really that better together and making Windows 10 the most secure operating system that we've released to date. So we start, obviously, with protecting the device, the hardware layer. We go to the threat resistance. That's where Windows Defender itself sits, Edge, Windows Defender Device Guard, a lot of the other technologies you've heard throughout the week. Identity protection, information protection, and at the end, there's a good chance you'll get malware in your organization. Okay, that's probably pretty safe to say. At that point, you want post-breach. We have Windows Defender ATP, Advanced Threat Protection. Very interesting offer. I highly recommend you look at it. Obviously, we work well together, but you can actually use it even if you currently have a different AV, and vice versa. So let's start talking about how we gather and where we gather some of those big optics and where we are. Well, we'll start with the endpoint. We are, with Windows 10, on every endpoint. We're sitting there. We monitor a lot. That's great for IT folks. That means your deployment is as simple as not really deploying anything, setting policy, and getting it down to the machine. But the agent itself is already on the box. By the way, same thing for Windows Defender ATP. Then we go to servers. So with Windows Server 2016, we're on most of the SKUs. We're on by default on most of the SKUs. But there's a lot more than just being on a server. We'll talk about it later, how to optimize for a server. But, oops, sorry about that. We also protect the Microsoft services. So we can see what's going on Office 365, Bing, Azure, Skype, and a lot of these assets, a lot of their data flow through Windows Defender so that we can protect them better, but then in turn protect the users that are using Windows Defender as well. And obviously, we're Microsoft, so we dog food our own dog food, or eat our own dog food, excuse me. Microsoft IT uses Windows Defender as the primary AV on the hundreds of thousands of computers that are used by Microsoft employees, including some servers. So let's look at these numbers, these huge numbers. You might have seen some of them throughout the week, the Microsoft Security Intelligence Graph. 1.2 billion computers, unique computers that we see on a monthly basis. Over 200 billion emails a month. The Windows Defender Cloud Protection Service, the one that your endpoints kind of call in to ask, and we'll obviously show a lot more about that. Over 1 billion calls a day. 2 million file samples. That means if we're not sure about a file, we get it, sometimes manually, sometimes automatically. 2 million unique files a day throughout the world. And that really feeds into that huge trove of data that includes metadata of over 80 billion files and 2.5 trillion URLs that were indexed. So crazy amounts. I'm really excited about them. But you might be asking, well, why do we need all that data? How do we use it? Well, let's look at the malware ecosystem. There's a few hundred families of malware that are introduced into the wild on pretty much a monthly cadence. So if you go into malware encyclopedias, those are the ones you'll see there, right? It's not a huge amount. But malware authors are getting more and more sophisticated. They obviously keep wrapping them with new evasion techniques. So sometimes even on an hourly cadence, you'll see a malware, then there's a unique version of it. But then they go one step further, and they've got command and control centers that offer unique files. Sometimes, something like 85% of the time, when we see a malware, we never see that instance again. So we see some files only once, and that's about 85 or 90% of the files. Though the remaining 15% or so are the ones that really cause the most economic harm. And kind of a question out here, some of you that have seen our previous session might know the answer. So how many days do you think it takes a malware really to achieve its economic harm, to infect most of the computers it's going to infect? How many days? Do you have this? OK, 2 days here. Any guesses over here? 1 day. Or guesses. OK, well, sorry, I set you up a little bit for failure. It's actually 7 hours. Within about 4 hours, the malware is going to, the computers are going to see that malware, about 30%. Within roughly 20 hours, that's it. The amount of computers that are really going to see that malware are 0. Within 7 hours, it's infected most of the computers. So 4, 7, 20 hours. We're talking about hours, not even 1 day. But when you think about signatures, kind of that traditional way of protecting our customers, they just can't be out there as fast. Even if you have the best deployment technology, you use machine learning, you auto-generate your signatures, you pass them through different quality tests in your organization, and then you ship them out. I say we as Microsoft, but that could be any competitor. Well, as you know, you probably don't want your endpoints in your company try more than 2, 3 times a day to download new signatures. And so there's always going to be that inherent delay. People are going to take a while. Their Windows update didn't update something. And so today's protection really is way too reactive, and we need to find a better way to do that. And that's what we're going to do via the cloud. And Randy now is going to come up and demo how we actually use that huge data to protect us.
OK, thanks, Amitai. So first off, let's talk about cloud protection. I saw that Amitai asked how many people are using SCEP, how many people are using Windows Defender. Lots of hands. That was great. But then when he asked how many of you are using Windows Defender Cloud Protection, I didn't see a lot of hands up. And so let me set the stage by talking about the role that cloud protection plays for Windows Defender on your endpoints. So the scenarios I'll be demoing will be file download scenarios. So that's let's talk about that. So when a user downloads an attachment, in this case, or opens an email attachment, or gets a file from some source, the Windows Defender client using the scanning engine is going to scan that file and try and make a determination with those signatures that Amitai talked about that you push out probably through WSUS or something like that. And it has heuristics, it has some lightweight machine learning type classifiers that get trained in the back end and sent down to the client. And in most of the cases, the vast majority of the cases, a new file, suspicious file, potential threat, the Defender client with just the scanning engine is able to make a determination and reach a verdict. But in a lot of cases, it can't, and that's where the cloud comes in. The client will basically make a quick cloud call. It's very lightweight, but send the information that it has extracted about the file up to the cloud, and that's where the cloud is able to apply those big optics and all that data that comes from those various sources that Amitai mentioned, the billions of files, URL reputation, file characteristics, and can then make a determination that, hey, this file is malicious or clean, and tell the Defender client to let it run. So there's 2 main scenarios in that case. And the first one, the cloud is able to make a determination just based off of that information that gets sent up. And in most cases can block just based off of that. And the second case is we need to actually get a sample of the file into our backend to do deeper processing and then learn about it by applying detonation and machine learning and really take it apart. So I'm going to show both those scenarios. And we'll start with what we call block at first sight. This is where the Windows Defender Cloud Protection should be able to make a decision about the file just based off of the telemetry and metadata that gets sent up from the client. So I have two machines. You can see they each have a targeted attack mail from an attacker. So two different users, two different machines. Hey, looks like something from my IT department. I guess I should install this. It says click to download and install, don't wait. The first thing I'm going to do, so let me put on my attacker hat for a second. So I've already sent this mail to these two potential victims as part of my malware campaign. And what I'm going to do first is generate a brand new malware file. So as Amitai said, on a regular cadence, attackers will make changes to their file so it will foil AV detection. And that's what I've done. I've just created one of those AV evading wrappers that he talked about. And just to show that this is truly a new file, how many people have ever used VirusTotal? Yep, quite a few hands. So I'm just going to search for this hash of the file that I just created. You can see it's not VirusTotal, no smoke and mirrors. Oh, let me mention that this demo is going against our live protection service. This isn't going against some sort of internal version. This is the same service that any of your computers running Windows Defender with cloud protection on would be connecting to right now. Oops, I didn't mean to close that. I'll need that later. OK, so I've generated the file. And now, so this link that's in each of these emails is pointing to that newly generated threat. So the first thing I'll do is turn off cloud protection. I don't recommend this, but for purposes of the demo, and since a lot of you run this way, I'll go ahead and turn off cloud protection. And now I'm going to download this file. So let's go ahead and download it. And at this point, Windows Defender will scan the file using local signatures. And Smart Screen is throwing me up an error. Smart Screen is doing its job. It's trying to say, hey, this looks suspicious. Don't run this. But my IT guy said I should run it, so I'm going to ignore Smart Screen. And I'm in a bad way here. So I guess I need to send some money to this guy and get my files back. OK, but let's switch to the machine that does have cloud protection on. Again, this is pointing to that exact same file, so nothing has changed. So we'll go ahead and download it. And we'll be scanning it. And then Windows Defender is going to make that call out to the cloud to say, hey, this looks suspicious because I have cloud protection on. Cloud, do you know anything about it? And you can see Windows Defender with cloud protection was able to block it. So let me talk a little bit about, well, how are we able to do that? What's the difference between this computer over here that didn't make the cloud call and this one that did? So in this case, again, we didn't send the file up to the cloud. We were able to, very first person who encountered it that asked the cloud about it, we were able to block it. And let me show you the logic that we were using in the cloud. So one of the things that we've invested very heavily in, using all that data, those big optics that Amitai talked about, is machine learning. And so we have machine learning classifiers that take all that data, these huge data sets of known malware files, known clean files, and then they can, we train those machine learning classifiers against all that data. And then we basically take that trained model and put it inline in our cloud so that when we get this query, we can basically run it against that machine learning model and make a decision about whether or not this is malware based on the confidence that that model returns. So let me go ahead and show, in this case, so I don't know if you noticed the file, I didn't point it out, but it was named svchost.exe. So this is a common technique malware authors use. They'll rename certain Windows components. And so I'm basically, this is the logic of the rule, I'm looking for a set of, if the file is named like a Windows component, like in this case svchost.exe, and it's not signed, so it's not digitally signed, or it is signed, but the signer is not Microsoft, which is already getting pretty far along. And one of our machine learning classifiers classified this file as malware. So again, when the cloud basically checked with this machine learning classifier, oops, I guess I left Skype running. Hang on a sec. My meeting got canceled, apparently, back at the home office. And so in this case, you can see I'm looking for a confidence score higher than 85% from our machine learning classifier. So in this case, all those conditions were met when we asked the cloud about it, and so we were able to block it. Again, this is blocking the very first time this malware was encountered in the wild, and by a machine that had cloud protection enabled. So let me go ahead and show you the second scenario. So this is the majority case, but there will be times when we need to actually get a sample in. Let me switch to another attack email on both these machines. Oops, wrong one. And I'm gonna do the same thing. So I've already sent my mail. In this case, I'm gonna generate, once again on my backend command and control as the attacker, a new file. And I can, once again, just show you that, oops, it is not in VirusTotal. And I'll also show you, so file not found, not in VirusTotal. And I'm also going to show you, this is checking our backend. So this is our own sample store where when we do get suspicious files uploaded for analysis, this is where they go. So you can see here, file is not in sample store. So again, I've generated a new file. It's not something that we have or have seen yet. And I'm going to go ahead and go through this. Oh, let me turn cloud protection back on before I forget. On this guy. So he is able to participate. And I'll go ahead and download this new malware sample on this guy. And so in this case, so this is running anniversary update. They both are. And this is where we've done some improvements, and I'll walk through the details of what's going on here in the background in a second. So I'm going to go ahead and run. You can see this malware ran. And what I want to show, though, is that when I recheck that hash, you can see now I get some metadata back from our, actually, let me do it this way so I can show you something else. So you can see that now this file did hit our sample store. So what happened is that first computer, even though we weren't able to detect it, we detected it was suspicious and uploaded the file into our backend. And you can see I already have here actually, there we go. I already have a machine learning classification from scanning that file that determined this file was malware with 95% confidence. And the main thing I want to highlight here is that you can see the creation time. So again, this is over on the right. This is the time that the file hit our backend. So when that first user, when I just downloaded that file, this is when it hit our sample store. So before we let it run on the client, it was uploaded to our sample store. And you can see it was at 02:17. And actually, you can see the time that we classified it as malware using this machine learning classifier was also 17.51. So it took less than, it took about half a second, less than 1 second, from the time that we very first got this file into our backend. Again, a file that we weren't able to classify without getting it in and doing deeper scanning on it. We were able to do that analysis and determine this file was malware in under a second. So if I now switch to this other machine, which a second ago, if I would have downloaded here, would have also been infected. Let me go ahead and download. We should see that Windows Defender through the cloud will now be able to block this file because the cloud now knows that it's malware, and you can see that through that malware classification. And no. Well, let me make sure I did that right. Generated the right file. So that should have been blocked. I'm not sure why the cloud call may have timed out. The Wi-Fi here has been not the best. Let me do that one more time. OK. So let's go ahead and go back to this guy. We'll give it one more shot here. I'll run through this quickly, and then I'll explain a little bit more about what was happening here on the back end. OK. Let's try this one more time. So again, we're going to run. This wasn't able to run until we uploaded it to our sample store. So again, if I check this new SHA, new file hash, we should see that we now have it in our back end. And again, we can see if it got that classification. Creation time 0544. Looks like it was classified as malware in the back end. 0545.8, oops. So a little less than 2 seconds that time to get classified as malware. And let me go ahead and switch back to this guy. And unless for some reason it's not making the cloud check, it should get blocked. OK, let me. All right, well, for some reason, it's not getting the block back from the cloud. I'm not sure what's going on there, but apologies for that. You should have seen that file get blocked just like the first file that we detected was blocked. But for some reason, we're not getting blocked back from the cloud. So let me go ahead and so we'll do a session later, and I have a feeling it has to do with connectivity. But let me switch back to the deck here and talk about how this works. If I'd been able to successfully communicate with the cloud, you saw that on the cloud backend we had classified it as malware. The cloud should have sent back a signature. And let me just walk through exactly what we did. So we had our attacker. I sent the 2 emails to the 2 victims. And then you saw me generate that new malware file on the back end in my command and control. And when the first user clicked and downloaded, we scanned the file and determined that this file looked suspicious. We didn't have enough information that it was malware. So we sent that up to the cloud and said, hey, do you know more about this? And that's where, on the first scenario, we came back and said, based on just applying that inline machine classifier, just using metadata, we were able to determine it was malware and blocked. But in the second case, we were not able to make a determination on the client. So we asked the cloud, and the cloud said, I don't know, but go ahead and give me a copy of the file so we can do deeper analysis on our back end. So the cloud requested the file from the user. And this is what's new in Windows Defender in the anniversary update, is we don't release a lock on the file. So we hold it on the client until the file gets uploaded to the Windows Defender cloud. Once the cloud confirms that it has the file, at that point only do we release the lock on the file and allow it to run. And that's where you saw that first user got infected. And at that point, that's where we do that automated file processing, and where I showed you that within, in the first case, that's about a second, and in the second case, 2 seconds, we were able to make that determination that the file was malware. And from that point on, when the second user downloaded the file, if the cloud check had succeeded, which apparently was not able to check with the cloud for some reason, the cloud would have generated a signature, as you saw on that the very first part of the demo that I did. I sent that down to the client, and you would have seen it been blocked. So the key thing that I want to emphasize here is that, Amitai talked about how these malware campaigns, they're not on the order of days, they're on the order of hours to monetize. And with Windows Defender Cloud Protection, we can actually learn about these new malware as soon as they come out. And again, within a few seconds, the cloud can become aware that the files are malicious and start blocking them. So we've really reduced the time to protection from hours. So prior to the anniversary update and where we have this synchronous uploading, we would let the file run and then sort of try and get it collected on a background asynchronous path. And by that point, the malware is already run and often will obfuscate itself, prevent it from being accessed, and we have a very low catch rate. In this case, because we're not going to go ahead and let the file run until we get it into our backend, that's how we're able to go from sort of fighting where the malware authors are looking at hours, 7 hours to monetize their campaign, and so we're trying to get signatures out to the clients or process those files and get that all done within 4 or 5 hours. Now we've really stepped in front of that and have the ability to protect within seconds. So Amitai talked about those unique optics, and I just want to really highlight the importance of how we're taking these, all this data and this huge corpus of information that we get from all these services so that we integrate with. He mentioned Office 365, the data we have from Smart Screen, all the telemetry we get from all of our endpoints. And we're really taking that and reasoning over it to build these machine learning models that learn what does malware look like and can take some new file that we've never seen before, but match through these ML models that, hey, and as you saw, 95% confidence that this matches this particular malware family. And then we can classify all those files that we're getting telemetry on using these machine learning models. And as we saw in the demo, at that point, the cloud knows that it's malware and can start blocking them on any other machines we see them on. And we can also use then other techniques like fuzzy hashing algorithms where, based on all this data, we have huge sets of what we know about, and we can say, oh, we know this file is clean, or we know this file is malicious in the cloud, once again, by reasoning over all that data and applying things like, these different algorithms. And finally, this provides intelligent ways to decide what files are suspicious and request those samples like we saw in the demo. And get those uploaded into the cloud where we can process them on a more deep level and then make a decision about whether or not it's malware or not. And then just real quick, I think I'm running a little hot on time. So I'll just go really quick on this slide. So I just want to talk about we're in the anniversary update. We've gone to this point where that first user gets infected. Even though we've got the file in, and you saw it can take only just a few seconds to determine that it's malware, kind of the next step in our roadmap is to look at how do we get to the point that we can build the right experience so that even that first user who's uploaded the file, we're able to come back and block. And so that's where we're headed. So we're trying, if we don't need to get the file in, that first scenario that I showed where we can block just based on metadata, then we protect patient 0. And then in the second case where we do need to get the file in, you can see today we let patient 0 get infected and then start blocking for patient 1 forward. But we really want to get to the point that even for brand new malware where we do need to get the sample in, we can come back and protect patient 0. All right, and back to Amitai.
Thanks, Randy. So how many of you guys believe Randy's demo would have worked? Wow, way more than I thought, so I don't believe it. We actually have a website open. It's part of your Ignite packet for this talk, where you can try this at home computers, anything with anniversary updates, so you can see that what didn't work here actually will work. You don't have to trust us or believe that it will work. So we're talking a lot about the cloud. I kind of want to bring us back to the endpoint. So we're not just traditional signatures, even there. Let's start with the actual blocking sides. So there's the anti-malware scan interface known as AMSI. Some of you may have heard of it. Open, any anti-malware company can use it, go into this API. What Windows Defender really does to shine, especially with the anniversary update, is we really take advantage and we do scan VB scripts, J scripts, and PowerShell scripts. And we take them and we deobfuscate them. So we understand what they're actually going to try to do. But then we take it one more layer, because that script in itself might actually be dropping a file that's another script and might be running a script and evaling. So we really go deep to understand what's going on. And that's super important, especially in these days of ransomware, because a lot of ransomware comes through these scripts. So that's a cool feature kind of we do. We're also a system-protected process, obviously, so a lot of the work we put is to harden ourselves, harden the anti-malware, because the last thing you want to do to happen is that a malware actually tampers with your anti-malware. right? As far as monitoring, ETW events, probably most of us are familiar with that. They're all over it. In Windows 10, we also have the concept of secure ETW events. Those are events that are only available to some applications, including Windows Defender and other anti-malwares running on Windows 10. Again, we take advantage of that and actually look at behaviors happening through the eventing system of Windows, as well as the network traffic, so that we can really understand what's going on and block it at that level. And earlier I talked about server, right? So it's not enough just to be on a server SKU. Servers are not just another desktop. We optimize for server SKUs. So as we're talking about containers and Windows containers, we make sure that if you've got dozens of containers, or maybe even hundreds, on a specific instance of a server, we don't go and scan that same file on every container. They're going to have the same image. They might have the same files. Let's scan it once. Let's be very optimal with it. Another thing that's really interesting, especially for companies, and this is why this thing is only available for companies, potentially unwanted applications, or what we call PUA, because potentially unwanted software doesn't really get a great acronym. So what is PUA, if you have not heard of the term? Well, the world is not black or white, right? It's not malware or clean, especially at an organization. There's grayware, right? There's something in between. There's something that, if I was on my home computer and I'm going to a kind of shady website and downloading some installer, I'm OK with. At a company, we might not want Bitcoin miners on our computer or all kinds of installers installing things. So we enable you through SCCM, Intune, or any way that you have group policy, basically to turn on PUA protection. Currently, it's off by default, but you can enable it. And what will happen is if one of the users in your organization goes and tries to install one of these, they will get blocked at install. And you will get telemetry about that and understand what's going on. I'm happy to announce, actually, that recently we've crossed 2,200 large companies using this feature, even though it's only been available for something like 6 months. And the graph on the bottom right is from one of our large customers that has agreed to kind of show some of the data. And this is how much PUA they've stopped in its tracks over 1 month, where our protection has gotten better, and they've deployed it to more and more of the computers in their organization. And that really helps them with the worker productivity, but also with help desk calls. Because the first thing that's going to happen when one of these applications gets installed, and then you can't uninstall it, and it slows down the computer, is your help desk is going to get called, and they're going to waste a lot of time and effort removing them. But like I said before, I don't want you guys to only trust us. We weren't great. A couple of years ago, we were not. As you can see with AV test scores, we were literally 0 a couple of years ago. Now, that isn't to say our protection capabilities weren't great. They actually were. But it's a relative score. So our competitors that we worked with actually were doing just better than us. Over the past couple of years, we've greatly improved both our protection, in an absolute term, but also relative to our competitors. And as you can see, we are going up. But I don't want you guys to use only, an AV test score, because they fluctuate. Every month is slightly different, and statistics. Our trajectory is up, and the difference between the best and the mediocre today or Defender are really fractions of percentages. And you can see that. You'll see where Defender is and where the top and where the mediocre are and where the bottom is. They really are percentages. The other thing is a lot of things that Randy has talked about, the power of the cloud, and able to stop malware that actually is prevalent is really important. Some of these tests don't look at prevalent malware. They kind of throw out all kinds of malware that really isn't out there, like stuff from years ago. The other thing is obviously blogs and news organizations kind of quoting us. But what I personally connect to the most is customers, people that didn't use Windows Defender, that suddenly are like, this is interesting. And again, like I said before, IT really loves it that it's on the box. When people try it in their own organizations, they're like, hey, AV test scores, you guys are pretty good. OK, let me try it. They actually find that we're awesome. One company tried it, got 99.5% block with 0 false positives. They're like, wow, this works in my organization. I know what I threw on it, and I knew how you guys handled it. When we talk about malware, there's also a great resource, the Microsoft Malware Protection Center, MMPC. You're going to see Malware Encyclopedia there. You can learn a lot more about these different things, blogs. Another thing that you can do, especially as commercial customers, you can actually upload samples of files. So we talked about the automated way. But you know what? You got infected. Maybe you're even using one of our competitors. And you think this sample actually is malicious. Or you know that it's not malicious and you want us to know. You can upload it there using your enterprise ID. And our team of researchers will take a look. And we do not have a guaranteed SLA. So we're not promising anything. But in the most part, within a business day, they'll usually get back to you. And if and when they do, you'll actually get a link to signatures before kind of it goes into the wild, so you can quickly send it down your machines. Again, there's no SLA, but usually within a day. There are special contracts you can do with Microsoft also around that. I think they have a booth around here that we can talk. Another great thing that we've done, well, our UI. It sounds kind of okay, UI, but you guys are anti-malware. One of the things customers love about us is that we have a simple, clean UI. We don't do a lot of pop-ups and nudging you and take performance from you. So that's one thing. We kept that. But we also listened to the other customers that were saying, you guys even run on my system? I've never seen you. So we really did enhance those notifications. We made sure to have kind of that good split between annoying you and not annoying you. So we do have periodic kind of notifications coming and telling you, your computer is clean, and let you know that you're protected. The other thing, big thing that we've heard, Windows Defender offline. So sometimes you'll think you have a rootkit, or the anti-malware will tell you have a rootkit. With the latest releases of Windows 10, we have a one-click solution for Windows Defender offline. So you don't need to go to a different computer, USB stick, put signatures, reboot, do all that manual thing. You can actually, whether it's that Defender prompts you, or because you kind of feel suspicious, you click that button, it reboots, it does everything for you. We also have some automated ways you can do this, which we can talk about and you can read online. But I don't want you guys to leave this room without my call to action. If you're not using Defender, try it. Turn on cloud protection. As I mentioned, in the material, you'll see a unique invite code to our kind of test site that you can test this out or throw whatever you want. Send us feedback. Our emails are wdcustomer@Microsoft. We're also on Twitter. Obviously, if you're a Windows Insider tab program, you can contact us via those methods, or join if you're not. Really great. Like I mentioned, we also have kind of Windows Defender Advanced Threat Protection, really complimentary, has great dashboard and monitoring, because as you can see, we don't talk a lot about that there. Take a look at that as well. Look at the MMPC and TechNet, and we'll have about time for 1 or 2 questions, but Randy and I will stick around in the room for any kind of more one-on-one conversations. So yeah, if there's just microphones, because I think there's other people also live streaming.
Do you want me to show the site, since I forgot the test ground site?
No, I think let's leave it on our site. So yeah, just come on up to the microphone so that.
So the cloud protection, is that only available in the anniversary update?
No, actually, that's even available in Windows 7.
Say we're using Configuration Manager, we wanted to enable that. Is that the same thing as maps?
Great question. Yes, absolutely. So we're trying to align our namings. Microsoft Active Protection Service is kind of that new Windows Defender Cloud service. People didn't love maps, the name. They're like, telemetry, you're collecting data about. We really want to be very clear that it's to protect your org. Maps advanced if you're in SCCM. The other thing is auto sample submission on. That's in the advanced area of System Center. So make sure those 2 are on.
Perfect, thank you.
Someone else said? Yeah, do you want to come on?
So in restrictive server environments where we can't allow the agents to communicate out to the internet, what's a good method for handling that?
So we don't have any on-prem version of the cloud protection. So it is an HTTP call, but yeah, we don't have. I know it's something that people have been asking for, but right now you do need to have an internet connection out to at least the wdcp.microsoft.com endpoint. So I don't know if you can open 443 just to that address, but that's all you need is, it's literally just an HTTP connection. But if you're not able to do that, then we don't have
it looks awfully compelling.
And I think at that point, if they don't have an internet connection, often they might not have those threats that are as pertinent, right? But we do have Windows Defender Device Guard and Application Guard, so there's a lot of other ways. Yeah, there's a question in the back.
Oh no, there's a response.
Oh. Yes, Michael.
Actually, to your question, all of our services run in exactly that environment. You can set up a web proxy that goes internally out of your internal restricted area and from there redirect. So it's simple configuration and it's supported by Defender.
Cool. Last question?
What licensing?
Actually, so Defender itself, I mean, it's in any SKU. You don't need anything else. It's the management that you would need a SKU for. So let's say you want to manage it via SCCM or Intune. That might be E3. I think Heike can give you more about that. But you might have your own management tools or dashboards. That's totally fine.
So I'm already SCCM, I'm already E3.
If you're SCCM E3, you're perfect. You can manage us through one of those tools.
All the cloud stuff.
Absolutely. So all these cloud things, they're actually in any SKU, Windows Pro, Windows Enterprise, anything. It's kind of in there, and the management is what you would need to.
And I heard you say Windows 7 support?
Yeah, so I mean, again, I don't, like you saw, some of the newest things with cloud protection really need the endpoint anniversary update, but some levels of the cloud, absolutely, even in Windows 7. So, we want to thank you again. Feel free to come here. We're sometimes at the Windows security booth. And if you have any one-on-one questions, you can definitely take them.
Thank you.
Thanks. And fill out the survey, please. It really helps us know what to do next Ignite.